What's up, you freaking geniuses? So in this video, I'm going to teach you how to identify all the basic transformations of exponential functions. All right, so let's start with translations. So here we have g of x is equal to 4 raised to the x minus 3. Now, whenever in our exponent we have x plus or minus some number, that just means we're going to shift our graph left or right. And you always want to take the opposite sign here. So since there's a negative 3, we actually want to shift our graph positive 3 spaces to the right. If you think of it, a number line, positive 3 would be to the right. Now here we have g of x is equal to 4 raised to the x plus 2. So again, just taking the opposite, we would think negative 2, right? So negative 2 spaces, or just 2 spaces, to the left, okay? Here is g of x is equal to 4 raised to the x plus 5. We don't have another number up here, but we do have a number at the very end, a plus 5. So that would indicate shifting your graph up 5 spaces. And then here, g of x is equal to 4 raised to the x minus 7. Again, this number just shifts it up or down. So here it would be down 7 spaces, okay? The other thing about these numbers at the very end is they tell us where our asymptote is. So when you graph it, for this graph, or this function, we would have an asymptote at positive 5. Y is equal to positive 5. And for this one, we would have an asymptote at y is equal to negative 7. All right, now let's talk about reflections. So here we have f of x is equal to negative 7 raised to the x. So if you ever have a negative sign out in front of your function, like we do here, that indicates a reflection in the x-axis, all right? And then over here, we have f of x is equal to 7 raised to the negative x. So if your exponent is ever negative, that would indicate a reflection in the y-axis. All right, now lastly, let's talk about vertical stretching and shrinking. So here we have h of x is equal to 3 times 5 raised to the x. Now you can see we have an additional number out here in front. So whenever you see a number out here in front, that indicates vertical stretching or shrinking. And if this number is bigger than 1, that would be a vertical stretch. So this one is a vertical stretch, all right? And how much are we stretching it by? Well, we would say by a factor of this number, which is 3, okay? Now, over here we have h of x is equal to 1/4 times 5 raised to the x. Again, we have a number out here in front, so that means vertical, right? And if the number is between 0 and 1, it would be vertical shrink. Okay, and in this case, we would say a vertical shrink by a factor of 1/4. So vertical stretching and shrinking is intuitive. It makes sense. So if the number is big, or if it's bigger than 1, it's stretching, it's getting bigger. If the number is smaller than 1, it's getting smaller, it's shrinking. And then horizontal is basically just the opposite of all that. So here we have h of x is equal to 5 raised to the 2x. Here you can see we're multiplying a number by our x, so that indicates horizontal stretching or shrinking. So here we would have horizontal, and in this case, since the number is bigger than 1, it would be horizontal shrinking. And here we would say horizontal shrink by a factor of 1/2. And the reason it's 1/2 is because you take the reciprocal of this number. So the reciprocal of 2 is just 1/2. Now here we have h of x is equal to 5 raised to the 1/3 times x. Again, we're multiplying a number by our x in our exponent. So this would indicate a horizontal. And in this case, since it's smaller than 1, it would be stretch. Okay, and again, this would be by a factor of 3/1, which is just 3. Okay, so those are all the transformations. Now let's combine all of this into graphing these. So if you found the video helpful, definitely leave a thumbs up down below. And if you have any other questions or want to see any other examples, just let me know in the comment section below.